So let's consider an oil that's flowing in a pipe. The pipe has a diameter of 0.03 meters, and the oil has a viscosity of 0.40 Newton second per meter squared, with a density of 900 kilograms per meter cubed. And what we're looking for is what is the volumetric flow rate if you have a pressure drop of 30 kilopascals in a 10-meter section of pipe. Now, normally the first thing you would do is calculate the Reynolds number so that you could determine whether the flow was laminar or turbulent. But here, because we don't have the flow rate and therefore we don't have the velocity, we're going to have to assume laminar flow and use the equation and then go back and check whether it actually is laminar. So for laminar flow, our Q, or our flow rate, equals delta P times pi times the diameter to the fourth divided by 128 times mu times L. And if we put in our pressure drop, remember that's 30 kilopascals, so that's 30 times 10 to the third pascals. Our diameter is 0.03. Our mu is 0.40 Newton seconds per meter squared, and our length is 10 meters. So if we calculate this, we find that the flow rate is 1.5 times 10 to the minus fourth meters cubed per second. But now we have to go back and check the Reynolds number to see that this is an equation that we can use. So we find our average velocity, which we would use in the Reynolds number, which is our Q over A, which is 1.5 times 10 to the minus fourth meters cubed per second, divided by pi d squared divided by 4. And when we calculate this, we find that our velocity is 0.21 meters per second. This is our average velocity. So our Reynolds number, which is rho v d over mu, and by the way, it's important that we use d as the length scale in the Reynolds number for pipe flow, not L, or the length of the pipe. And so this equals our 900 kilograms per meter cubed times 0.21 meters per second times 0.03 meters, all divided by 0.40 newtons seconds per meter squared. And when we calculate that, we find that the Reynolds number is 14.2, which is certainly less than 2100, which is the critical Reynolds number, and we can use the equation that we used.